Hello, everyone. Welcome to the last meeting of our AI engineering book club. Today, we are going to talk about the last chapter in the book, AI engineering architecture and user feedback. So there are three goals that we want to achieve in this chapter. The first is that we want to bring these techniques together to build successful products. Second is that we want to gradually add components to address challenges of the simplest architecture for foundation model architecture. Lastly, we are going to talk about user feedback because user feedback has been becoming more and more important as a data source for improving the models and user experience. So first, let's dive into what is the AI engineering architecture and how does that differ from the traditional system design architecture. So in its simplest form, to start with, your application will receive a query and send it to the model. The model just will then generate a response and then send back to the user. So basically, you can think of just a wrapper of the LLM API. Then you can add more components as the needs arise. So there are 5 components which the book recommends. The first one is enhance the context. So essentially giving the query additional data. Second is putting guardrails. Third one is add the model router and gateway to have support compact pipelines and more security. The fourth component is to optimize for latency and cost with caching. And the fifth one is to add compact logic and write action to maximize your system's capacity. Think of as AI agent. So from this perspective, you can think of agent as just one simple type of the general AI engineering architecture. Then let's dive deeper into each of the components and how it looks like and what it requires. The first one is to enhance the context. Context can be constructed through different ways. First is text retrieval, or to retrieve image or even traditional tablet data from a relational database. There are a lot of tools that are available to allow the model to automatically gather information through APIs. And also, more traditionally, you will just connect it with the database, such as for the RAG application, where you would find the relevant information through vector similarity search. The second one is component. After you have the context, but to have more security, you want to put in the guardrail for both input and output to the foundation models. For the input, the main reason you want to do that is to alleviate some risk. So there is the risk of leak query information to external APIs or execute bad prompts and compromise your system. So for example, you don't want to have the API key or other secrets in the query that you send over to OpenAI's API, especially if there's no guarantee that they will not use your user's input to train their data. So there are a lot of tools that can automatically detect the sensitive data and help to remove this data, or basically put a mask so that it cannot be identified. And second, if you show the model's output directly to the user, then it's very important to put the guardrail to the output. Essentially, you want to catch the output failures. But the problem here is that what you define as a failure. So here, you want to first understand what different behaviors from the model output and define different failure modes. For example, in terms of quality, the output could be malformat, like you want the model to output a JSON, but maybe it's not a string. Inconsistency answers, or sometimes just a bad response, it's not actually answering the question. Security-wise, the answer could be containing toxic, sensitive, or private information, which would also lead to a lot of issues if you expose that without any guardrail or actual protection and cleaning to the user. And lastly, it's very important on the point about fallback on humans for tricky requests. So it's very common use case in the chatbot where the user would ask a lot of things, sometimes maybe beyond a chatbot can handle. And instead of having the chatbot to directly connect with the general API, instead you define the chatbot to only respond to certain queries and requests, such as finding the order status or maybe find some information about the logistics of that order. But you don't want that to answer other questions beyond that domain. So if user asks these questions, you can instead connect the chatbot to the actual human agent for these tricky requests. So how to implement? Because as you can see from this graph, is that it's adding more components, which would mean more latency. So this is a concern, especially when you use a stream computation mode, where just think about when you are using ChatGPT, you see the AI basically types the answer word by word. If your application has a similar UI, and then having this guardrail might not work. However, if you do think guardrail is worthwhile, the reliability versus the latency trade-off, there are a lot of third-party APIs which can greatly reduce the guardrail you need to implement. Next, let's talk about adding the model router and gateway. So to start with, why do we even want that? Why don't we just call the API to say OpenAI or Gemini? Well, as we can see from the past years, neither one of the models is perfect or can achieve our goals, or even the stronger model could be expensive. Say for OpenAI or Google's models, there are a lot of different tiers. Some are more expensive and more capable, and some are smaller model, also cheaper, but might not perform very well on the complex task. And also, sometimes the model will just be down, where it will not be answering any of the requests. So that's the one we want the router. So router is that like we have different solutions for different kinds of the queries. So in this case, we can have specialized models for specific queries. This is just like you can think of, you have a group of people, and then if the work task is more difficult, you would assign that to the most experienced person, while the simpler task, maybe you can assign that to the more junior employee. So this way you can save the cost. Another very common use case is intent classifier. This means the classifier would route the request to the appropriate solution based on the predicted user intent. And this will also prevent the system from engaging out of scope conversations. This is a very common use case for the chatbot. And also, it will be very useful for the next action predictors, where this router could aid the model in deciding what to do next. And the common pattern here is that the router will route requests, and then for each of the tasks, it will do the retrieval, as we talk about in step 1, adding more context. And then the generation will basically call the actual API. Scoring, as we mentioned earlier in previous chapters about evaluation, we want to have the model or maybe another call to calculate and measure the response, such as the hallucination scores. And then we have the gateway. So gateway you can think of as a unified wrapper for the different models, which you are allowed to use. So there are a lot of benefits of having the gateway. The first is you can have access control and cost management, monitor and limit the usage of API calls, fallback policy to overcome rate limits or API failures. And lastly, load balancing, logging, and analytics. So I think from an enterprise perspective, this is extremely helpful, because otherwise you can think of each team try out different AI POCs. Some might be using OpenAI, and some might be using fine-tuned model, Llama model example. And then the code is not unified, and it's very difficult to manage, and also very difficult to control the budget as well. So usually the machine learning platform team will build some sort of gateway, a wrapper, API, or library, where the application downstream team can just use this library and then simply put the model they want to use as a input parameter. And this way, the central platform team can control the access for each team. What's the quote and budget they have, and what's the access they have for these models. For example, if it's not a really AI team that need to use the model, then probably they do not need the access to the expensive ones. They might just because some teams that might just be doing the POC and not for the production use case. So this way they probably could just have access to simple open source models. And here is a visualization of how this looks like. So you can see instead of generation and scoring, we have in a box called model gateway. And the gateway will do all the routing and then the generation and scoring. So let me provide an analogy here while I'm reading this. So think of the model gateway as the airport, because for example, different people have different needs for traveling. And for example, and then airport essentially is a gateway where people can go to different places. It's the same unified format. It's very also access control as well, because when you go in, people will check your IDs. Routing is essentially is that when you arrive at the airport, then depending on where you are going and which airline you are taking, domestic or international, United Airlines or JetBlue, and you are going to the different gates. So this is basically the simple way to think about what's the difference of gateway and router. Step 4 is to reduce the latency with cache. So definitely, as you from your experience, you might have seen times when the LLM API took a lot of time to respond. And also, especially when you are streaming the LLM response to the UI directly, the latency is extremely important. So this one on cache, essentially we want to reduce the latency and cost. And this is needs some engineering work in terms of the system caching. The first method is exact cache. So essentially, if the user, same or other user asks the exact same question, and then if the answer to that question has already been generated before, and we save that in the cache, and then we will retrieve that from the cache and serve that directly. So this is similar to the traditional software system design, where we use a database, commonly like Postgres or Redis, which is more optimized for cache, or even if it's a output as an image or unstructured data, we can have the tiered storage, bulk storage on S3. And the next one is the semantic caching, because in the traditional software engineer, when we're thinking of caching, it's more about retrieving or some search result. Usually it's the exact caching, but for this case, lots of the time it's more human language, where another request might not be exactly the same with the previous request, but could be semantically the same. So that's when the semantic caching could be a method, where it will have a vector database to store the embeddings of the cached result. And then for the incoming request, it will calculate a cosine similarity with the existing caches to see if any existing one, if any of the similarity scores exceed certain threshold. And that, if that is the case, we think that the new request is semantically the same or similar as the previous one, and then we will just serve the user with the same result as before. However, this is only worthwhile if the cache hit rate is high. Otherwise, it could introduce more latency. So this is how it will look like in this design diagram. So the user, which is the happy smiley face on the left, sends a request. It will first look up in the cache, and if not, then it will go through the all the generation and process. And in this case, if the once answer is generated, it will also save in the cache, so that when the user sends the request again, it will this time on the left cache button here, it will have that response. So step 5 is to add the agent pattern, which is a hot trend right now. So think of the agent pattern is where the flow can be more compact with loops, parallel execution, and conditional branching. And outputs can also be used to invoke write actions. So that's where the write or the agent pattern different from the traditional pattern, where you want the agent to directly perform some actions for you, such as update an order, send an email, or place an order, or place some decisions for you. So that's when really you can expand the capacities for the product that you're building. Okay, so basically you can this graph is the final ideal stage for your AI engineering product architecture. But yeah, different depends on your use case. It will be different than having more or less more fewer components than this graph. But in general, you can think of that you want the cache to reduce the latency and cost. Optionally, write actions to better serve the user's needs. and definitely some database to either serve the cache or the other AI responses. Guardrails for both input and output to have remove the PII and add the security measure. Also the model gateway and the routing, where you can have centralized and wrapper so that you can easily do the AI governance. So similar to the software engineering, for the AI product, we also need to have monitoring and observability. And there are two goals we want to achieve here. The first is to mitigate the risk. There are lots of the risks in terms of application failures, security attacks, and drifts. Second is to discover new potential opportunities, application improvement, and cost saving. And there are also a lot of the metrics for measuring systems observability. So let's dive deeper into the metrics monitoring. So this is around design your metrics around the failures, such as format, factual consistency, or sometimes you want to see whether the generated answer has good quality or not. It's very important. Point here is that you want to measure how these metrics correlate to each other, and especially to the business North Star metrics. So this is actually the same principle as we have in the ML ops world, where, well, first we want to track, say, the accuracy score or F1 score for your machine learning prediction model. But these metrics don't make any sense for your business stakeholders. So you want to clearly articulate that whether there's like 10 or 20% of increase in this metric, what it mean for the business metric, such as daily active user, profit per user example. And also you want to measure the latency metric, as we mentioned earlier, and if it's high latency, you might want to see how to remove some unneeded components or adding the cache. Cost related measures, because you need to set the budget and also closely monitor whether how these APIs are accruing the cost. So next one is about logs and trace, which are two different terms. Logs are append-only record of events, so basically all the, whether it's informational or debugging purposes, record of events. Logs can be pretty messy because it's a huge list of the events. And the trace is the detailed recording of the request execution path through various system component and service. So essentially, some tools want to provide the trace of basically when you request, make a request to the API and what is its execution path. Then this way you can clearly see for each specific to that request, what each step would take, what time it took, and what the if it has a failure, which step causes the failure. And also about the drift detection, which, well, drift is really a term used in ML ops when talking about the data drift, where the input or training data has a lot of the changes where will cause the model to behave differently. Similar here is that the system prompt will change, the user behavior will change, and also very often the underlying model will change. So different examples for underlying model change is that you need to do a lot of the version control and the making sure that you also log the particular version of the model you use to generate the output. So this way you can not only do the comparison, but also making sure you are serving the best response, no matter which model version it uses to the user. Otherwise, if you just say OpenAI release a new model and then you just update the model name in your code without any versioning, it could be possible that the newer version of the model would have worse response than before. So having all these mentioned, then we are going to talk about AI pipeline orchestration. So there are the two main parts. One is the component, another is chaining. So component is that what are components in the AI pipeline? So we have different models, external data sources for retrieval, and tools that your system can use. Chaining is where we combine these different components together. So orchestration here will be responsible for passing the data between the components. So this is how we think about the AI pipeline versus the data pipeline as a for data engineer. So the Airflow especially is also a chaining of different of the tasks. However, these tasks usually do not communicate with each other. Or well, we only define the dependency of these tasks, but it's very difficult to pass the data between these different components in a traditional orchestration tool. But for AI tool, essentially underlying the data is flowing between these components, right? Because we first, the data is that we add the context. The guardrail tool essentially also is examines the data, and then when we pass that to the API, it also use that data and then give the output as well. And then output guardrail will also look at that output data. So when we are evaluating the tools to use for orchestration, then we need to think about three aspects. One is the integration and extensibility. Second is support for the complex pipelines. And the last is ease of use, performance, and scalability. So this is all about the architecture and system design piece for the AI engineering. Now let's talk about the user feedback. So why we want to collect the user feedback? So because it will give us a competitive advantage of proprietary data. Also, using the user feedback, we can further personalize the model for individual users and train future iterations of the models. Then you can think of the feedback on two categories. One is the explicit, such as thumbs up and down, up vote, down vote, star rating, or yes or no answer. So this make user very easy to give you feedback. The implicit one are basic information inferred from the user actions. So let's dive deeper into the conversational feedback, which are the two parts. The first part is natural language, another is non-language. So on the language feedback, you can say in a chatbot application, there are lots of signals. The first is early termination, if the user terminates the response early, or if the user corrects the previous answer, which I feel I use a lot when using the GitHub Copilot, when the response does not understand what I want it to do, and then I will clarify that no, I mean something else. Or user edits to the existing response as well. So this indicates it's an error and gives the feedback to the engineers behind that product as well. Complaint is that when user complain about your application's output without trying to correct the messages saying, oh, this is not good. Sentiment is general expression of negative sentiments. So, the other conversational feedback. So here we have the regeneration. If the user chooses regeneration, it might be because they are not satisfied with the first response, or such as user would reorganize the conversation, such as delete, rename, share, or bookmark, and also the number of turns per conversation and distinct token or token content. Okay, so now we understand why it's important to collect the user feedback and how should we design the different ways to have those feedback. So there are different times when we can collect feedback. Beginning is when a user signs up, then we can ask user some questions to help calibrate the clarification for the user. This is very common in lots of the applications where you would ask some further questions so that the experience will be personalized. When something bad happens, you can give the user the option to download or generate or change to other model. Or the model has low confidence, user can also choose which one they prefer. So this is actually a technique that OpenAI or also Gemini use a lot. When sometimes you see the model will generate two responses, left and right, and then will ask you to choose which one is better. So it's almost like a testing where they would collect all the user feedback, and then in the future they know what sort of answer you might prefer to see. How to collect the feedback. So there's several tips. It shouldn't disrupt user experience and should be easy to ignore. Should be incentives for users. For example, what is there for me to give you the feedback? For example, if I click this button and give you feedback, I know in the future I will get better user experience. Then I think this is a good incentive. It's commonly seen is that a lot of the application will have a pop-up window. Would you mind rate us in the App Store? And then I think usually people will just ignore. But if the application say if you rate, then we give you some extra credits or certain incentives within the app, then it was just a motivation for people to do that. You also want to explain to users how their feedback is used, because user is very sensitive on sharing detailed information. And also don't ask the user to do the impossible. Example here is that when the user don't know the exact answer, and then you give the user different options and which one to choose, it will be basically you are not collecting really good feedback from the user. There are also some limitations when looking at the feedback data. Bias. There are different types of bias from human psychology. So the latency bias, where people more compelled to be nice because it's the easiest option. So if you want the user to be more critical, you should be think about way to alleviate this bias. Randomness, where they just give like a random answer without thoughtful input. Position bias is where user will find the first suggestion or basically the options appear at the earlier index looks better for them. Preference bias, where the user usually think the longer response is better. And also about the degenerative feedback loop. So this is similar to exposure bias, where the YouTube will recommend some videos, and then you are more likely to see the videos on the top ranked pages. And when you watch them and like them, then in the future it will recommend more similar videos like that. But potentially there are some other videos initially show up at the later local runner, but maybe you would like those videos similar or better. So that is also a potential bias there as well. So here is a brief summary of this chapter. So while the exact architecture for application might vary, but this high-level architecture provides a framework for understanding how different components stick together. So online, there's a lot of people talking about, AI engineering just a wrapper of the API, which is in some ways true, but still there's a lot of engineering work and designs needed to fit these different components together. So it's just much more than just calling the API. Second is observability involves understanding how your system fails, designing metrics and alerts around failures, and ensuring that your system is designed in a way that makes these failures detectable and traceable. Lastly, more AI engineers are now becoming involved in the process to ensure they receive the data they need. Because in this way, you really need to work with the product team to think about what feedback that we want to collect from the users and design an application in the way where user can easily and confidently give us accurate feedback. And then together we use those feedback to improve the product. So that's all the summary for this chapter. Sharing. Okay, thanks so much for listening. And that is the last chapter for the AI engineering book. And thank you so much for participating and listening to the previous workshop meetings. So in the future, I'm also going to post more AI engineering related videos, such as project demos, interviewings, as well as deeper dive into how the leading tech companies are implementing the AI solutions on this YouTube channel. So if you haven't subscribed yet, I highly recommend you subscribe. Really appreciate your support. And if you have any questions, feel free to ask me or schedule a coffee chat. And with that, I will end this meeting.